This episode will jump right back into our 4L60E rebuild and start working on the input drum. After checking for wear on the bushing surfaces of the turbine shaft of the input drum, we'll go ahead and remove the 4 Teflon sealing rings. Like with most things, there are many ways to do this, but what I find the easiest is to use a pick to lift out the ring from the side, and then it can be stretched out a little bit and simply cut off. The point of the pick should stay away from the turbine shaft, and care needs to be taken to not gouge any surfaces. And of course, it's also possible to remove the rings without cutting them, like we did for the stator shaft. Whatever works for you, and doesn't end up in the shaft being damaged, will work just fine. Once all the rings are removed, we'll want to hold the drum in a vertical position so that we can easily access all the other components. When we rebuilt the 700R4, we used a 1-inch hole saw to drill a hole through a 2x4 and clamp that in the vise. For this rebuild, we'll use that same procedure and the same board. And all we have to do is slot the turbine shaft of the input drum through that board, and everything will be held in place. Now that the input drum is held in place in front of us, we can remove the snap ring that retains the 3/4 clutch pack. This is the same type of snap ring that we removed from the transmission case, so we'll use the same method to remove it. This snap ring isn't quite as stiff, and the access to it is a bit better, so this one is easier to remove. We'll simply twist one big flathead to move the ring away from the case, and another flathead screwdriver to lift it up. We'll work our way around the drum like this until the ring comes out. And with that removed, we can lift out the 3/4 clutch selective pressure plate. It's basically a beefier version of the other steels in this clutch pack. And then we can remove the 5 clutch boost springs from the drum. A lot of rebuilders don't like to reuse these and simply leave them out when reassembling. But in this case, we will be reusing them, so we'll put them aside to reinstall later. Next, we'll grab the whole 3/4 clutch stack up and lift it out of the drum. It's a good idea to keep these together and remember which order everything came out in. The stock setup for this transmission is 5 steels, 6 clutches, and then the 3/4 clutch apply plate. Next up, we'll remove the forward clutch snap ring, which is a little bit tougher, but can be removed using the same method. Once again, we'll work our way around, lifting up as we go until it can be removed from the drum. Then we'll grab the input sprag and use it to lift the forward clutch pressure plate out of the drum. In this case, the top clutch came out stuck to the pressure plate. And now we'll lift the forward clutch stack out of the drum. Again, we'll keep these in order so that we can reassemble the new ones in the same way. Then we'll grab the 2 overrun clutches and plates and lift them out of the drum. We'll also remove the thrust bearing and oil seal from inside the drum. For this next part, we're going to get a little creative. We need to remove the overrun piston return spring, and to do so, we need to compress it and remove a snap ring. I had planned to make a little overhead spring compressor with some 2x4s, but for time reasons, it just didn't happen, and we'll use the same method I used when rebuilding the 700R4. For this method, we'll use a piece from a ball joint puller set. It's just a steel sleeve that's 3 inches in diameter. What we'll do is place it over top of the overrun clutch return spring and pry down against it using 2 long screwdrivers through the holes in the sides of the input drum. This method is definitely a little fiddly and not the fastest way. Of course, there are tools for this, but they can get pretty pricey. It wouldn't be too difficult to make a press that uses a bit of leverage to make this easier, but in a pinch, this trick will work. Last time, I had a helper hold down the screwdrivers to remove the spring more easily, but this time, thanks to the horseshoe snap ring pliers, it was possible to do it alone. Using this method, it took just a little over a minute to remove that snap ring. And with that out of the way, we can release pressure on the return spring and remove it from the drum. Just like the return spring in the case, you'll want to try to keep it from getting caught in the snap ring groove. Next, we can grab the outside edge of the overrun clutch piston and lift it up out of the drum. And then the forward clutch piston comes out as well. The forward clutch housing and the 3/4 clutch apply ring can be a little tricky to remove, so what we can do is simply turn the drum upside down and bang it against the bench a few times. And now, we can separate the 3/4 clutch piston, the 3/4 clutch apply ring, the 3/4 clutch return spring assembly, and the forward clutch piston housing. And then we can use a pick to carefully remove the forward clutch piston housing inner O-ring. To help the check ball in the input drum seat as well as possible, we'll take a small punch and give it a tap with a hammer. And then we'll give the input drum a thorough cleaning. We basically just hosed the drum down with brake cleaner and carefully wiped everything off. And now we're going to go ahead and clean out the oil pan so that we can use it to soak the new clutches in transmission fluid. We'll wipe down the interior of the pan and then remove the pan magnet. And after one final wipe with a little more brake clean, we'll pour some transmission fluid into the pan. We don't need to fill it up all the way, just enough to let everything soak. We'll go ahead and get the new clutches out of the rebuild kit and place them all in the bath of transmission fluid. Taking this step of soaking the clutches is very common but not universally practiced. The idea is to make sure the friction material is fully saturated with fluid before the transmission starts to turn. This should hopefully help ensure that the clutches don't break in too hard. This late model transmission uses steel pistons in the input drum. These steel pistons have molded on seals that are not individually replaceable. To replace the seals, you simply replace the set of pistons in the drum. Some models used aluminum pistons, which were prone to cracking, so it is desirable to replace those as well. Before installing anything, we'll give all the new pistons and clutch steels a thorough cleaning. It's a good idea to check using calipers and visual confirmation that the new steel plates and clutches are the same dimensions as the old ones. The sizes are pretty standard, but sometimes thinner or thicker steel plates and clutches are used. Having the correct clearances in the input drum is very important, so it's good to know that everything is the right thickness. We'll give the inside of the input drum one final cleaning to make sure there's nothing left in the corners and grooves. To help get everything installed, we'll give everything a liberal coating of oil. And then we'll install a new oiled O-ring into the groove in the drum. And with the O-ring installed, we'll apply oil to the new 3/4 clutch piston and slide it into the drum. Getting these pistons reinstalled into the drum without tearing any seals is one of the trickier parts of rebuilding these transmissions. This piston should pretty much slide into the drum, and it will be the easiest of the pistons we have to install. And next we'll drop back in the 3/4 clutch apply ring. We'll keep adding more oil and drop in the 3/4 clutch return spring. And we'll slide the forward clutch piston housing into the drum. Getting the forward clutch piston installed can be a tricky task. To help with this, we'll use two small pieces of transparency film. One will help guide in the far edge of the outside seal as we tilt and twist the piston to get that seal into the housing. And once that's in, we can remove that outside piece of transparency film. The next step is to get the inside seal of that piston seated on the shaft inside the drum. The other small piece of transparency film will help guide it in, as well using the handle of a hammer to gently tap the piston into place. Just like installing a bushing, we'll keep tapping on the perimeter of the piston and moving around in a circle. It helps to start with the piston at a little bit of an angle and then tap it down until everything lines up straight. If part of that inner lip seal isn't cooperating, a thin blade on a feeler gauge can be used to help guide everything into place. Once the piston seal is completely below that beveled edge, we can remove the transparency film. There are special tools specifically for installing lip seals that can be made or ordered. Use whatever tools and methods work best for you. And now that the forward clutch piston is installed, we'll add even more oil and install the overrun clutch piston in the same way. And after a little bit of fiddling to make sure everything is lined up, we can push it into place. Now that all our pistons are finally installed, we can drop back in the overrun clutch return spring and get ready to reinstall its snap ring. We'll place the snap ring on the outside edge of the shaft so that all we have to do to install it is push it down into the groove. We'll get our spring compressor set up back together and push the snap ring down until it locks into the groove. Trying to do this without any helping hands is a bit tricky, but putting a socket in that drum next to the steel sleeve helped get even downforce to get the ring fully installed. Make sure the snap ring fits fully inside the retaining tabs on the return spring assembly. We'll also install a new shaft oil seal and reinstall the thrust bearing. We'll want to thoroughly oil every thrust bearing we reinstall. We can do this by dipping the bearing in oil and turning it in both directions to work out all the old fluid. It's a good idea to repeat this process several times for each thrust bearing. We covered most of the information about the input sprag in the last episode. Ideally, you would remove the snap ring, holding it all together to examine the internals. But, at the very least, you'll want to hold the outer race firmly against the workbench and make sure it turns freely in one direction and locks hard in the other. We'll go ahead and finish wiping down all of the clutch steels with brake clean. We want to make sure any factory oils or other contaminants are removed. Now, we'll use the old clutch stack up as a guide and install new clutches and steels into the input drum. First up is the overrun clutch stack, which starts with a steel plate, and then a clutch, then another steel, and another clutch. I find it easiest to install the input sprag now and build the clutch stack up around it. It can be a bit tricky to get all the splines lined up and everything installed otherwise. So with the input sprag in the drum and turning freely, we'll continue stacking up these clutches. Next, the forward clutch apply plate goes in. We're reusing the old one since these aren't typically included in rebuild kits, so we'll make sure it's nice and clean. The next steel plate is a special one. It's the forward clutch wave plate. If you take an up close look at it, it's easy to see why it has this name. The wave plate isn't flat and acts as a cushioning spring between the different clutches. So on top of the forward clutch apply plate, we'll drop in the wave plate, and then one of the new steel plates for the forward clutches. And then the first forward clutch, which will have to line up with the splines on the input sprag. And then a steel, and then a clutch, 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 and then finally we'll reinstall the old forward clutch pressure plate. And with that put back together, we'll reinstall the forward clutch pressure plate snap ring. Since this ring is so stiff, it's difficult to bend it by hand and get one end started, so right away we'll pry against it until we can get one end started, and then work our way around until the whole thing snaps into place. And with that locked back into the case, we need to check the forward clutch clearance. We'll do this by inserting a feeler gauge between the snap ring and the forward clutch pressure plate. Before we rely on any of the measurements we take, we need to make sure the snap ring is evenly pushed up against the top of its groove. And with that taken care of, we can check this clearance with the feeler gauge. This is doable with a straight feeler gauge, but an angled one would make this a little easier. This forward clutch clearance measured right about 50 thousandths. That's a little towards the high side, but for this truck, it'll be totally fine. To close that gap, they make thicker steel plates as well as different size pressure plates that you can mix and match to get the clearance you're looking for. But since our clearance is looking pretty good, we'll move on to the 3/4 clutch pack. Once again, we'll lay out the old stack as a guide and start cleaning all of the new steel plates. Once that's taken care of, we can resume reassembly by installing the 3/4 clutch apply plate. And then we'll start stacking up our new 3/4 clutches and plates. The original setup used a total of 6 clutches for the 3/4 stack. The new setup with these aftermarket steels and clutches will fit 9. The 3/4 clutch pack is one of the main weaknesses of a stock 4L60E. The majority of the time, it will be these clutches that get burnt and start slipping the soonest, especially in an old or abused transmission. Adding more clutches to a stack spreads out the load and increases holding ability. The extra clutches are fit by using thinner steels in between them. In a higher power application, the thicker steels can help distribute the heat better, but here, the thinner ones should be just fine. Once our clutch assembly is most of the way installed, we can drop back in the 3/4 boost springs. And then, one last thin steel plate, and then the 3/4 clutch backing plate. This snap ring is much easier to install than the other one. And with that installed, once again, we'll need to check the clearance. This can be checked between the backing plate and the snap ring, but it's a good idea to check between the backing plate and the top steel so that you're not feeling any compression from those boost springs. With the new higher density clutch pack, the clearance for this came out right about 40 thousandths. That is a good tight clearance for this stack. And now, other than the sealing rings, the input drum is completely back together. But before we go any farther, we can air test the pistons in the drum to make sure everything is installed correctly. In between the sealing ring grooves, there are 3 ports on the turbine shaft. If we apply air pressure to the bottommost port, we're engaging the overrun clutches. The overrun clutch piston has a check ball in it which feeds air to the forward piston as well. It's a good idea to block that port and listen for any leaking air. We can demonstrate how applying these clutches works by turning the input sprag. When the sun gear is turned clockwise, the outer race and the forward and overrun clutches turn with it. But when air is applied to that bottom port, both the forward and overrun pistons engage and the clutches are pressed together. If we apply air to the middle port, we're only feeding the forward piston, which engages the forward clutches. Applying air to the topmost port engages the 3/4 clutches. We're checking that all the pistons are moving freely and retracting as they should. This tells us that things are assembled correctly and the seals are holding. So the next step is to install those 4 Teflon sealing rings. The process is a repeat of installing the Teflon seals on the oil pump stator. First, we'll clean the area up and make sure there's no debris or splinters on the turbine shaft. We'll also clean out the sealing ring grooves as best we can. Then everything gets a good coat of oil. Just like on the oil pump stator shaft, we're going to be using transparency film to install these rings. First, we'll use an oiled piece of film to get the rings past the splines on the turbine shaft. And then once the ring is down towards the grooves, we'll use the film to get the seal down where it needs to be. The film is protecting the Teflon rings from sharp edges and preventing them from stretching any more than they have to. Be sure to hold each ring in place on its groove as the film is removed. Since it will have stretched a bit as long as most of the ring is in the groove, if one edge comes out, as shown here, it's still easy to get it back where it needs to be. So that's how we're installing the rings, but there's 3 more to go. So now that all 4 seals are installed, we need to compress them. Once again, we'll use zip ties to accomplish this. One by one, we'll pull them nice and tight, making sure not to pinch any seals in the process. And once each ring is compressed, we can slide the zip tie off of the ring and carefully cut it off. And there we go, 4 nice new sealing rings for our input drum. In my experience, these rings are ready to go after just a zip tie resize. The larger seals on the stator shaft benefit from the electrical tape wrap, but it's not necessary for these. So, for a final test of many of the involved parts, we'll slide the oil pump onto the input drum the same way it will be when everything is installed. Great care has to be taken to put the 2 parts together so that none of the Teflon seals get hung up and damaged. Well, at least we tried to put the parts together, but something was wrong. The parts should easily fit together, and that's not happening. The oil pump would install a certain distance onto the shaft and then not move any farther. We quickly realized it was because the front stator bushing wasn't fitting over the turbine shaft. As mentioned in the other video, the bushing did seem like a little bit of a tight fit when it was slid over the turbine shaft without being installed, but now that it is installed, it doesn't fit at all. So let's pull everything apart and check on that bushing. So yeah, we can pretty conclusively say that that's where it was getting hung up. We can see it was getting caught on this edge, and there's actually a little bit of bearing material on the splines at the end. These cheapo calipers aren't the most accurate, but they've actually treated me pretty well so far. According to them, this shaft is exactly or just under an inch across. But when we check the installed bearing, it's actually a little bit smaller. So I'm not too sure what's wrong. My best guess is that this bushing was just made a little undersized. Maybe to compensate for wear in the turbine shaft, or maybe it's a defect. I really don't know. What I do know is it's simply not going to work. So I went ahead and ordered a new bushing. Well, actually I went ahead and ordered 2. Just for good measure, I ordered a wide one and a narrow one like it originally had. The narrow one is about 1/2 inch wide, just like the original. The wide one is a little over 5/8 of an inch wide, just like the one we installed. Going by the calipers, the inner dimension of both new bushings is a little bit bigger than the turbine shaft, and a test fit of each confirms this. Unlike when I test fit that other bearing off camera, these bushings have a nice relaxed fit over the turbine shaft. Now you're not looking for a loose fit, but it shouldn't be tight either. Since the bushings are a press fit in their bores, they will be compressed a little bit. So the ideal starting size is a little bit of wiggle room on the shaft. So, in order to get a bushing that fits correctly on there, we have to remove the one we installed in the last episode. We'll set the oil pump back in our holding fixture, but this time, instead of prying the bushing out, we're going to push it out from the other side. We'll use some masking tape in order to protect the rear stator bushing from any errant scratches. What ended up working really well was using an old 3/8 inch extension. By putting the female side up against the bushing and hammering on the other end, it was able to push the bushing out of the stator fairly easily. Since everything had been cleaned, we didn't want to spread debris around by destroying this bushing to get it out, and also since it had never heated up and cooled down while in that bore, it shouldn't be too stuck in. And pretty soon, thanks to some careful hammering, the bushing was pushed back out. Now we'll flip the pump over and make sure everything is squeaky clean again. We also want to make sure there's no thread locker residue left in the bore. Before installing the new bushing, let's double check to make sure the wide bushing isn't too wide and getting bottlenecked by the taper inside the shaft. But nope, the taper doesn't start until at least 71/100ths into the shaft, so even the wide bearing wouldn't touch it when installed flush. So we'll cross our fingers and go ahead and install the new wide bearing. It's the same process as the first time. A little bit of thread locker, place it in the stator, a little bit of careful hammering using the backside of a socket, and just like that, we have a new bushing installed flush to the front of the stator shaft. We'll go ahead and clean everything up and remove the protective masking tape. We'll check the new bushing with the same digital calipers, and yep, it's definitely reading larger than that last bushing did. So we're all a go for test fit attempt number 2. We'll get the input drum back on the bench, apply a fresh coat of oil, make sure all the sealing rings are still centered, and slide the oil pump down onto the input drum. There's still a little bit of resistance as it slides over the Teflon sealing rings, but that's to be expected. The bushing slides onto the shaft just fine, so we're in business. And once the oil pump is fully installed, it spins easily and freely, even without a thrust bearing installed. In order to visually inspect the rings for damage, we'll go ahead and remove the oil pump and check them out. Everything looks good, so we'll go ahead and reinstall the oil pump, and it should go on even easier this time. Yep, it's a perfect fit. And with the input drum and oil pump still together, we'll do another air test. We'll hold the two parts together and place them upside down onto our fixture. This time we'll be applying air to ports in the oil pump. There are 3 ports here, and we'll be using 2 of them for testing. The first one applies the reverse clutches, which aren't really in play right now. The second one applies the 3/4 clutches, and the third one applies the forward clutches. We can see that when we apply air to that first port, it just leaks out and doesn't go anywhere. When we apply air to the 3/4 clutch port, it applies just like before. And the same goes for applying air to the forward clutch port. All the pistons are moving as they should, and all the turbine shaft seals appear to be holding. The leakage you're hearing is simply between the tip of the blowgun and the ports. A typical rubber sealing nozzle on one would prevent this. And with that final test, we're done with the input drum assembly. We'll go ahead and separate it from the oil pump so that both parts can be covered and stored until final assembly.